Slack. Check Slack. Thank you. It's okay.
All right, we have a note taker. Chris doesn't want to see us get hurt. All right, it's time to get started. Welcome to TLS at IETF 106 in Singapore. Oh, man. I'm sure you're all familiar by now with the note well. If you're not, please familiarize yourself with it. The blue sheets are now going around. We have a Jabber Scribe and we have a note taker. All right. So should we just get started with external PSKs? Yeah, okay. Does anybody, here's the agenda for today. Any additions or modifications? Any additions or modifications to the agenda? Yes.
With no hat on, semi-static goes nicely alongside compact TLS. I would prefer to not do that. We can move it before batch signing if that works for you.
I mean, we could move it before compact TLS if you really want.
Sure. Yeah. Can you, if you could stick to 15 minutes, that's fine.
I can do it in 12.
Perfect.
Any other requests? All right, on to external PSK. Oh.
All right. So this, we have like 15 minutes for this, but it shouldn't take that long. We've been talking about this for a while, importing external PSKs for TLS. There have been a number of updates since the last draft. In particular, we used to have this weird way to express like what was the protocol for which we were importing a PSK and what was the specific hash algorithm that you wanted to use to import that PSK. We sort of simplified things, and now the way you import and target a particular protocol is by saying this is specifically the protocol I want to use, the 2-byte code point value, and then here is the specific KDS for which I want to import this PSK. There is a new registry defined in the document for identifying these KDFs. Currently, it's just the TLS 1.3 KDFs, and if we have more in the future for TLS 1.12 or whatever, we could add them as needed. We also added a new slot to the import identity struct, which is this opaque context field, primarily to help mitigate and deal with the selfie attack. So the idea is that if you have a deployment in which selfie is relevant, fill out the contents of this context field accordingly. And there's guidance on how to do that in an appendix. And we also added some security considerations to the document where, as previously, they were just sort of TBD. And still, there's kind of still TBD, although we have started the analysis to sort of give us confidence that the imported PSKs do have the desired properties that we want. And ideally, we complete this before publication of the document. There are 2 outstanding PRs right now, the first of which is a clarification on the selfie attack. It rewrites the appendix in a way to help provide more crisp guidance. In my opinion, I think that a lot of it can be simplified by just stating that roles should be unique. However, the author of the PR is here to make the case. So,
Mohit, yeah, you can blame me for sending this pull request, and it may seem overly complicated, but one challenge I faced when I posted the paper on the mailing list is somehow people thought that this is a misconfiguration issue and not really a problem with the TLS external PSK. So maybe it was my poor explanation, but I'll use another example, and cheers, please let me have my minute of fame. So if Joe and I are chairing another working group and we want to have secret chat or communication, I call up Joe, we exchange a PSK and a PSK identity, and now he can open a connection to me and send a message, and I can open a connection to him and send an encrypted or protected message, and this is vulnerable to selfie attack, and the attacker doesn't need to know the PSK. So depending on how you look at it, some people say this is not group communication, this is client and server. Some people might say this is a group of 2 or group of 4 because both of us can be client and server. So I think there is many variations. It's not just that, oh, you are using PSK in a group and someone with the PSK in the group misbehaves can cause selfie attack. There is also versions of selfie attack where it's possible to do this without knowing the PSK. And this is the reason I had added that text that if the PSK is shared between 2 parties, you only need to make sure that the identities are, or the identity of the other party is not the same as yours. And if you share the PSK across a whole group, then you definitely need some better information about the identity. I also got a comment from Martin Thompson that this requires some kind of signaling. I actually disagree because you can't open a TCP connection without knowing like the MAC address or IP address of the other party. So you don't necessarily need the signaling to do that. I'm happy to make changes to the pull request, but my question to the working group is, shouldn't this be a errata on 8446, and like, shouldn't we fix it once and for all in this draft?
Martin, do you want to comment on that at all?
Yeah, Martin Thompson, it's really hard to do this without the text in front of me and the comments that I made. I forget what the signaling comment was specifically, but I wanted to sort of go to the core question here. I said that I think that may be a comment on the text, not the design as much. And I think there's a point in here that's really important, which is that understanding what role you're expected to play in here is critical. And the text in the appendix preceding this pull request was, I think, adequate to that task. Probably my biggest objection to the text here was it was starting to create new privacy implications that I think would regress the properties that we've already agreed exist in TLS. The signaling aspects of this thing I don't think are as critical to that.
So, sure. Mohit, so even the previous text was saying that you can use identities such as an MAC address. I just elaborated the text saying that if it's only between 2 parties, you only need to make sure that the MAC address of the other party is not the same as yours. But if it's shared by the group, you need some more protections. So kind of clarifying both the cases. Maybe TLS as a working group decides that PSK should never be shared between more than 2 parties, which is fine, but I'm sure people will still do something else. But that's a decision for you guys to make.
Yeah, I'm sort of viewing the PR as like I say, an attempted clarification of the existing text. So I don't have a strong opposition to it personally. I want to make sure that, to Martin's point, we're not like regressing other properties and introducing and trying to, flesh out more details about the mitigation, if that makes sense. Go ahead, Jonathan.
Jonathan Noyden, Cloudflare. I think the only thing we just need to make sure doesn't happen, and this is what I feel is the underlying cause of selfie, is that people assume that role and identity are in some way tied. And so, I had a few people suggest that, instead of just putting whatever your name is, they'll say, oh, just put client and server. And of course, that doesn't fix anything at all, because either party can be either client or server. So it's just about making sure that they have always different, which is not the same as always unique identities.
I mean, so as I understand the current text, or the design idiom here is to start with one PSK and create n squared PSKs, which basically correspond to the mesh of possible people talking to each other. Correct?
Yes.
And then in some unspecified way, in some unspecified way, figure out which PSK to use for any connection, right? Namely, like I'm aware of the identities, and like the system has some set of rules for like how I construct, for like I name people and how I and how I turn and what I shove in these context strings, right?
Yes.
So like that seems like a reasonable design, not the only one, but a reasonable design. And I don't quite understand, like, I guess I'm not understanding what the extent to which the text in this pair is different. It seems to be somewhat confusing and worse. Like I don't understand what it is recommended each endpoint / one global unique identifier using all PSK handshakes means. Like where is that how is that identifier used? I mean the text here is like. The text here is like I have some unspecified mechanism for picking the keys. So one thing is not. So anyway, yeah.
The current text just tries, to punt that sort of to the application, because that's strictly a deployment sort of problem. So that's the goal of the current text, and whether or not we need to be more specific in this particular document is the question, I guess. And my opinion is no.
So Ben Kadek, it seems to me like when we were doing 8446, we were thinking a lot about the resumption PSKs, and we sort of left external PSKs off to the side, and we didn't think about them too much. We didn't give them a full analysis for all the cases that might be applicable. So I think my suggestion would be to have a standalone document that sort of fills in those missing pieces and gives us like, these are the considerations for using external PSKs with TLS 1.3. And it can go into the analysis about how the identities come into play and what you need to do to avoid the selfie attack and other attacks, and the privacy considerations of those identifiers. Maybe even come up with ways to do like rotating identities so that you have less of a privacy issue. I think this could evolve into a pretty larger scope thing, and so I'm not sure we need to stuff it into the current document per se.
That seems reasonable as well. Mohit?
Two quick clarifying questions. Should we remove selfie from this document then and solve it in another document? Should 8446 have an errata? And do we as a working group want to allow use cases where the PSK is shared between more than two parties?
So I don't think we should remove any mention of selfie, because like we specifically added that slot to deal with, to like let this other draft that Ben just mentioned possibly exist, in the details about how it's used go there. I don't think we need an errata on 8446 to deal with this. And I'm not sure we can say much about like PSKs not being shared. I mean, applications will do crazy things and deployments will do crazy things. So, yeah.
Martin Thompson, I was going to get up. I got up specifically to say what Ben said. A lot of this is, I think, going a little bit further down the path of doing a design than we're comfortable with in this document. And to do that design justice, we need another document, because an appendix is definitely not the place to start embarking on something as complicated and as nuanced as this. And that's, I think, where my objection was coming from. And so if we can do this in another document and keep this high level advice, that would be fine. Recognizing the existence of the problem is kind of important because of this assumption Jonathan talked about. But yeah, all the stuff with how we agree on what the identifiers are and how you construct those identifiers and how they might be exchanged and built into PSK IDs or not is kind of complex. And I'd rather not do that here.
Yeah.
So what I'm hoping to do, what I'm kind of hearing is that, like, we know we have this problem and we need to identify and write it somewhere. So we need to mention selfie here so we have text already. So what I'm hearing is this PR gets rejected. We start another draft, possibly led by a design team to delve more into this. But that basically means when you reject this, we push this draft forward like immediately. Because does that basically sound like a plan? Is there anybody who's interested in joining a design team to look at these different issues? All right. So I see Hannes, Ed, Martin, Jonathan, Ecker, and Chris. Moore. Yeah. So plenty. So does that sound like a way forward? Does that work?
So I think I'm thinking this for a little bit now, and I think it's probably important to distinguish between several things which I think are not haven't been that well fleshed out in this discussion. So first of all, selfie is an active network attack by a WVO attacker. It doesn't none of the endpoints, right? And so it has two modes. One mode is confusion between, like, you're acting as both client and server for the same connection, and that's solvable in a number of ways, including basically comparing the key shares as John Matson has suggested. It's also solvable by basically splitting it so you have a client server. You only use one key share as a client, one key share as a server, and one client one server role. As a separate class of attacks, which are about rerouting between multiple clients and server pairs, and yet a sort of and the typical way to solve those problems is to have identifiers in the protocol as opposed to diversify the key material. And now so finally, to get to the point of the text here, right, is there's a separate class of problems, which is that if you have a group that all share the same key, then one member of the group can impersonate another member of the group. And that problem has to be solved by giving them individual keys. It can't be solved by expanding the keys this way and squared this way, because they still can all generate any group pairs at all. So without like an extremely long like wind up, I actually think that we should probably remove all this material, because the key diversification doesn't, because the proper solution to this problem is role identification in the handshake. It's not key diversification. And I think this is what Jonathan was alluding to earlier. And so there's one way to do role identification. The trivial role identification in the handshake, as I say, is this, like, is for the two-party case, it's just like the reflection comparison. And the n-party case actually is like put some identifiers in the second handshake, and don't treat the PSK identifier, which is a key mutual identifier, as an object as a user identifier.
I think we're getting a bit into the actual.
But yes, I think we should definitely reject this PR. But right. I think we actually should taking all the material out.
Right. So I think we've come to a conclusion, right? Basically, unless somebody's going to get up and radically scream at me, is that we are going to reject this PR. Then I'll kick off the process to move it forward. We'll form a design team to get some additional information up about selfie and how to deal with it. Is that?
Mohit, I won't lose sleep over rejecting this PR. That's fine if there seems to be consensus for that. Maybe my only quibble was if we are going to add identities to this, to importing external PSKs, at least the text could still give some guidelines on how to mitigate selfie. So the previous text, in my opinion, was not saying that the identity of the other party should be different from any of your own, and perhaps at least it could do that.
Jonathan.
It just boils down to a question of, do you trust everyone who has your key? And if you don't, then, like, why are we here?
No, it doesn't. I said in the first comment that selfie attack can be caused by someone who doesn't have your PSK.
Yeah. So there's actually one other outstanding pull request, and Jonathan, you might not want to sit down because it's just your pull request. So basically the idea is, the proposal is, in addition to importing an external PSK and doing the key diversification based on the protocol and the KDF, you also change the label you use in the binder computation. And the idea is that in some pathological case where the identity that some other application constructs happens to match an imported PSK identity, and the PSK is the same, that both parties potentially aren't in agreement as to whether or not a key was actually imported. Whether or not that's an issue in practice is less clear. So I think this is potentially something that like helps formal analysis. It gives us good. It keeps things separate. So maybe that's better. I'm not sure it's needed though. So do you want to comment?
Yeah. So I think it's needed as a general thing. I'm not sure it should happen here. My presentation later also has this change, and I think it fits better in the other document than here.
So
we should still use binder labels, but where those binder labels are defined, I think should move.
Okay.
Key schedule document?
Yeah.
Let's sort that problem out separately. That's document engineering, not protocol engineering. So I mean, we haven't accepted the other document yet, so they have to be here, right? So I've regrettably concluded that we have to do this. It makes me a sad panda, but like we just like had too many problems with people with complicated attacks where people would would take the drive key and then stuff it in some separate slot, like, I mean, the way to think of this is like we've introduced another rung in the ladder, right? Where, here's where the keys went in, and now have a thing and we put them in here, and I don't want somebody going in here, which is what this prevents. So regrettably, I think we have to make this change.
Great. Is anyone opposed to changing the label?
I'm not opposed. I have a process point, and that is please state your name at the mic.
Oh,
Yeah.
yes, thank you.
I forgot that part.
Great. So we'll work with Jonathan to tweak this PR and land it. We will reject the other PR, and then hopefully move forward, because there are no other outstanding issues for the document. Hannes.
Chris, very briefly. This is Hannes. I always feel a little uncomfortable if we make some of those changes just based on a gut feeling where we think there could be a problem, but then we don't really know. Because it always makes everything sort of implementation-wise more complicated.
True, it does change the implementation, introduce additional complexity. However, like there is a case where this is potentially a problem. The one that I outlined earlier, or sort of described on the slide. So that seems sufficient to me.
So we do know of an attack. It's just we can't think of an implementation stupid enough to make themselves vulnerable to it. That doesn't mean people won't be stupid.
Is the attack described in the document?
In your PR, it is not described in the pull request. The pull request just sort of describes what are the effective properties of the change, not so much what the motivation of the change is.
Yeah. It would be good to document the motivation as well.
Yeah, absolutely. In the security considerations, perhaps, Jonathan, we can add some text there. Actually, I think we're sort of out of time, but Martin, if it's quick.
Yeah, you were just summarizing. I realized in this discussion that I wasn't sure about something in the document. I just went back and checked. You say in here that there are no changes on the wire in the protocol except for expanding the set of identifiers that appear on the wire.
Yeah,
and it's a very important statement to make. But I also realize that you don't really expand on what it means to expand the set of identifiers. And I'm wondering whether or not there's a formal structure to those identifiers implied by the document, or whether there's an expectation that people work out what those identifiers are, because it's not very explicit in here. So I'd just like to raise one more issue on
the structure of the imported identifiers?
Yes. The PSK identifier that you use on the wire, I think the intent is to use the structure that you have in here, right?
Exactly, yes.
You need to say that very clearly.
Right. Yes, we can add a sentence. Can you file an issue for that?
I will file an issue.
Thank you.
Great. Excellent. I think is that it?
Yeah, that's it.
That's it.
Oh, yes, we're working on implementations, and hopefully when we're done, we can move the document forward.
Cool. Nick Sullivan, you're up for the next two.
Sorry, cut and paste. I'll fix that. So we're on the back nine for TLS exported authenticators. This bug, we're going to have a bug on both. So this has gone through last call, and it's gone through reviews. And essentially, there's one last point that needs to be addressed. This was raised by Yaron Sheffer. And it comes down to this specific line right here. As a reminder, TLS exported authenticators is a way to export a piece of data that corresponds to essentially a certificate request and then a certificate. It's useful for higher level protocols like HTTP that need to have the security of essentially the proof of ownership of a certificate, but without having to implement the crypto at a higher layer. It relies on TLS to do so. One of the use cases here for exported authenticators is for client-initiated server authentication. So this is a use case that's not present in TLS. So you can think of it as the server has already, you've already made a connection, the server's already authenticated for one certificate, and you want it to authenticate for a second certificate. And so the mechanism for doing that in exported authenticators is to create an authenticator request on the client, and then which mirrors what would be in the certificate request in TLS, and then the server responds with an exported authenticator, which contains the certificate verify, and finish message. Because in TLS, this is something that's always initiated by the server, the set of extensions that fit into the certificate request is determined by the list in IANA. So specifically, something like SNI is only a client extension, whereas not a server extension. And so this use case implies that you have an extension in certificate requests that's not allowed according to TLS 1.3. So the suggestions were to change the document to update RFC 8446, which seems like a pretty heavyweight change for this document that actually does not update this RFC significantly. The other suggestion is to kind of spin out a new extension point for SNI. That is basically an extension point that says this is an SNI, but it's in a certificate request, not an SNI that sits in the client hello. That seems like it also might be a bit of an anti-pattern there. You might have to, if there's any other extension that's going to fit into this, then you have to spin out a duplicate meaningful extension. SNI exists in client hello, so it's not defined in certificate request in TLS, but this is a certificate request looking structure. And then there's the third question, and the third option here is my preference, and I put up a pull request for this. But essentially, the certificate request-like structure in the client-generated exported authenticator request, treat it looking like a client hello when generated by the client with respect to which extensions you can add. So allow client hello valid extensions when this is allowed, and if it's coming from the server, allowed certificate request extensions. And these are the three proposals to help solve this.
All right. I'm clipping the line after Jonathan.
Right, good. I think this is the right approach. One of the things we did in TLS 1.3 was start to pull apart the various extensions and their roles, but we never really did that for client hello. And there are multiple different types of extensions that exist in client hellos. We have the ones that change the shape of the protocol. We have the ones that govern key exchange. We have the ones that are used in selecting certificates, and some of them are overlapping and they fill multiple roles. I think this is the simplest way to manage this by simply saying that, yeah, this is the client asking for a certificate. That's exactly what it does with a lot of the extensions in the client hello. There are some in here that won't make any sense, key share, for instance, but you just ignore those ones. It's fine.
Kyle Neckritz. I'm not sure if this is exactly what you're saying by C, but would it make sense to essentially treat this as a different message, like client certificate request, if we're going to have these like weird mismatch of requirements anyway?
If so, I don't think it makes sense to request a new column in IANA for this, but I think just one line of text here should be enough.
Ben Schwartz. With I like option C. My one concern is if you think of if you put yourself in the shoes of a bad server implementer, I wonder what kind of mischief could be created if, for example, you just said, "Oh, this contains client hello extensions. I'll just process whatever client hello type extensions show up in this field."
Yeah, it might make sense to just have a whitelist.
Aren't certain client hello extensions mandatory, which would make this very weird because you'd either be like, we ignore the mandatory ones.
Yeah, I think the text that I proposed does not say treat it like a client hello, just allow client hello enabled extensions. So it wouldn't have the mandatory requirement. It wouldn't be a client hello, it would be a certificate request looking structure that allows specifically one client hello extension, which is SNI. And
so yeah, a whitelist then sounds more reasonable because otherwise, like, what does the server do when they receive random client hello extensions?
Okay.
Yeah, I'm not sure what I do like, but I don't like C. I'm concerned of the same thing Ben Schwartz just raised. It just seems like really like what the heck does like Keysha mean here? And I don't want to ignore it. I want to like I want to follow draft IB. What's it called now? Estelle was wrong, and reject it if it's bogus. So I think we could discuss how to spell it. I have no problem with updating 8446 as a general matter. I haven't decided anything about the technical point, but update away.
How do you feel about just whitelist client hello? SNI, for example. I mean, this is the only contentious point is about SNI, and that's the only client hello extension used to select certificates that is relevant in this use case.
I'm not sure prepared to understand it yet, I think.
Okay.
All right. So more discussion required.
Okay, this is on the list, so please, if you have a comment, post to the list. Okay, this is also not CFRG. Whoops. All right, delegated credentials. This is another one that has been moving along pretty nicely. Particularly, we have an update here of running code. There's some public announcements of support for the draft version of this protocol in Firefox nightly, as well as Cloudflare, and Facebook has been doing, they have an endpoint that supports it and have talked about supporting it more thoroughly in their infrastructure. One of the issues that was raised at the last IETF that indicated there's another potential small issue here. This is really a flexibility issue, and it's not clear that there are too many stacks that this would affect, but one of the issues in TLS 1.3 that came up was this idea of having supported algorithms and supported algorithms certificate as two lists of supported algorithms, one for which SPKI is allowed in the Leaf certificate versus which SPKI is allowed to be used in the certificate chain for signing the Leaf certificate. And because the PKI stack is sometimes different from the TLS stack, these two things are potentially disjoint lists or different lists. In kind of polling the implementation audience here, there's sort of a dual overloaded use of the supported algorithms in exported authenticators. Exported authenticators does not use the Leaf certificates SPKI to sign the handshake. It uses the delegated credentials extension SPKI to sign the handshake. So there's potential for a mismatch here if your TLS stack supports an SPKI, but your PKI stack does not support that SPKI in assert. So the specific use case here is, say you advertise support for the ED 25519 signature scheme as a supported algorithm, and delegated credentials. And you support ED 25519 delegated credentials, but your PKI stack does not support extracting the ED 25519 SPKI from the leaf cert. Then you'd be in the situation where if a server supports this type of key and doesn't support delegated credentials, it could send down a cert that supports this key type, and your stack is not able to effectively communicate that distinction to the server. So this is not necessarily a problem in some of the stacks that we've seen, but it's a potential problem in one or two of the stacks, and I've heard anecdotally from folks that this may be a problem.
Yeah, so Martin Thompson, we were originally struggling with this problem with RSA PSS, which I don't think anyone's actually going to deploy, but the implementation kind of had to deal with it. So we sort of ran into a few problems there. We have multiple pieces of the stack and multiple pieces of the policy enforcement infrastructure that all have to support this thing before we can turn it on. Right. And it turns out that it's okay for us. At the point that we can turn on PSS generally, we'll be able to use it here, but I can see how others might be affected by this. I'm okay with this. I think that having a very small, controllable set of signature schemes for delegated credentials is a nice feature. I don't think it's absolutely essential, but I'm okay with this proposal.
Okay, yeah, I would imagine that the typical deployment will only have, say, 2 elliptic curve support and not, say, RSA of any sort supported. And yeah, this prevents you from having to deal with RSA-based delegated credentials if you don't want to.
So I guess, so your proposal is to put a field in the DC extension that is like, here are the algorithms I support?
That's right, just a list.
Yeah, I guess I like how you have live with it here, because I guess I can live with that, but I can also live with not having it. I think, yeah, I guess this is like one of these like beauty contest things. So I guess, is there anybody who feels strongly on one side or the other? Is there anybody who?
Kyle's stepping up.
Okay. But on a separate issue.
Okay.
Kyle Nekritz. I agree there's a use case for this, but I guess my question is anyone going to actually use this? I don't think we would use this to like advertise a different algorithm or advertise a different set of algorithms. So
as a client, you mean, or as a server? Because this is advertising as a client. Support.
Either. But if someone really wants to use it, then I have no problem with it.
Yeah, I think the reason that this will come into play is in moving forward with new algorithm types. It likely gives us more flexibility with adding new things, like, for example, on the semi-static DH side, we might be able to advertise in this without necessarily supporting semi-static DH in the leaf cert.
Yeah, Martin Thompson, I was just about to get up and say, let's not add something that when we don't have a good, clear use case for, but that's a good reason to do this. We have a little bit of trouble getting all of the different pieces in place when it comes to our certificate validation infrastructure, and being able to say do a PQ algorithm for DC would be kind of a nice way to experiment with those signature algorithms without actually having to commit to putting all the CAB forum rules in place, for instance.
So
right,
I think
or changing your, yeah.
So I think the summary is basically we're going to accept this proposal.
Well, let's hear what Hans has to say.
Well, I would like to comment on a separate issue, which is
okay.
Can I do that?
Yeah.
Is this
sure?
So the maximum lifetime of the delegated credential appears to me picked pretty randomly, and 7 days. So I wonder whether that's really a good idea in use cases that we are looking into. 7 days seems a little short, and I was wondering whether you can sort of motivate some the 7 days, or why I would want to do that rather than 5 days or 10 days. I understand that you ideally would like to put the number in there, but I'm not sure that's a great idea.
Yeah, it's a maximum, and it was based on the typical deployment of OCSP. So what works right now as the minimum for revocation and for short-lived certificates measured on the web is where we came up with,
and
with
OCSP in the web in context.
That's the context in which this came up.
Yeah. So Martin Thompson, this is really coming out of the web, right? We're basically assuming that this is a web deployment scenario. Maybe the right way to thread this is to essentially say that absent other information, endpoints should set a policy of 7 days maximum, but we leave it otherwise unspecified, so that those deployments that want to do things like, I don't know, putting a certificate on a camel that's going to then go across the desert and then have to be valid at the other end of it. I don't know.
So I guess, Hannes, do you have a use case for which you have a certificate that you can't shorten to the time that you want, but a DC that you want to expand to past 7 days?
I don't imagine that there's any case for that.
Yeah. All right. Cool. So,
yeah, I can't talk entirely about the use case, but it's originated in the IoT space, where some of the devices are not always connected, and so having them sort of connect to just to get the delegated credential just for the sake of fulfilling that sort of requirement appeared to be a little tricky, given that today their OCSP is not even used at all, let alone certificate revocation, which is more used in a sort of like firmware update sort of scenario. You can argue whether that's a good approach or not, but I think using that work, this recent work there in those environments would improve security overall. So I think Martin's approach of tying it or augmenting it into the specific context, and the web context, in the web context, that makes total sense to me.
Okay, so you understand the tweaks that need to be made based on Martin's?
Yes.
Yes, great.
Ben Schwartz, I'm not convinced that there's a web context in that is detectable or identifiable to the server operator who is deploying an HTTPS service. In particular, that they don't know what kind of client it is at this point. One thing that you could do is signal a maximum expiration lifetime in your client hello.
Yeah, Martin Thompson.
We discussed that and we decided not to.
This firmly fits into the I don't know what the client has in their trust store space. I don't know what their policies are. I don't know. There's a lot of that vagary already in practice. So I don't know that we're making it worse by making this one thing.
Kyle Neckrits, if we don't have a must on the validity, then I'm worried what we do on the client side. If we get a delegated credential that has a validity over what the client is willing to accept.
Right. I mean, the purpose of this is to ensure that the server never sends the client something with too long a lifetime than the client's willing to take. And so, right now, web PKI certificates have essentially an infinite maximum lifetime. Though, like Ryan Sleevey keeps dialing it down. But it's just like a rule, right? And so the client server have to agree on this, or if the server will tell the client something, the client server will make like a 2-year DC, and then the client will be nope, and then you're screwed. So and what you want is and so either we have to have a rule written down, or we have to signal it, and something that seems hard, right? I guess what I would suggest is that when we get to the point where there's an aggressive use case that needs a longer value, there's a way to signal it then. Now, if Hannes is saying I have a use case right now where I need super long value, then maybe we have to live with that. But I don't quite understand how real that is yet for you.
Yeah, I was wondering specifically also in the TLS specification we have some wording specific for the algorithms, the mandatory to implement algorithm, absent a specific profile. Those are the mandatory to implement algorithm, and I could imagine in this case it's similar. Absent to a specific profile, the default is 7 days, and
yeah, I'm good with that one. I guess the other change, this change, proposed solution of adding the list. I think let's confirm that on the list, and I'll just merge it in. And then I think at this point, with that change, I think we're ready for working group last call.
Sabo did ask in GitHub whether we should do an early code point allocation. Are there people that are trying to implement this now?
The answer is yes.
I mean, I think the answer is yes, but like, do you want me to like
already?
kick that?
It's already in Firefox.
So all right, so we should start kicking that process off.
Yeah, you think?
Okay, let's do that.
So actually, this is a bit of an agenda bash, but I'm going to do it anyway. We really need a thing like MT is invented for Quick, where we have provisional code point allocations, so that we can early or not, so that we can like do this kind of stuff, and so that we don't stomp on each other like by accident. Happy to do that. Yes.
So I'll start kicking off the early code point allocation process for that this afternoon.
Okay.
Thank you very much. We agenda bashed.
We switch the order.
Did you change your slides too?
Hi, everyone. Okay, so I want to talk about TLS extended key schedule. So why would you want to extend the key schedule? TLS has some like really nice properties, but maybe we want more, better, more exciting properties. Fine. For example, we might want some privacy properties for the client hello. We might want to do some sort of hybrid key exchange where we use quantum safe keys as well as classical keys. And the question is, can we achieve these new different properties without breaking anything? So we know that TLS has the properties we think it has because it's undergone quite extensive analysis, and modifying the key schedule might mean we have to redo a bunch of that. But it's non-trivial to get these new exciting properties if we want them without changing the key schedule. But it's also important that we don't create new attack surface. So I was motivated to do this because there are a bunch of drafts that are like, we want to change how the key schedule works, and we want to do this, or we want to do that. So for obvious examples, hybrid key exchange, if you want to be able to use a quantum safe key exchange simultaneously with TLS, without having to allocate new code points, you could just define yourself a hybrid key exchange draft, and this would let you include these keys and inject them into the key schedule without having to worry about, oh, do we define composite code points? Do we define, multiple lists? This just sort of walks around all of that. ESNI, as we're going to see later, there's been a bunch of ink spilt on whether we should inject into the key schedule or not. External PSK importers, how do we diversify keys before they're used by TLS, rather than having to have n-squared keys or whatever? And semi-static Diffie-Hellman also wants to adjust the key schedule to allow them to do various things. Okay, so what we need is an extensible framework. All the drafts I just mentioned modify the key schedule in mutually incompatible ways. And they generally haven't had huge amounts of security analysis, and they definitely haven't had security analysis of what happens when you use them with other key schedule modifications. And there is lots of dragons there. So this draft attempts to do two things: capture all of the work already done with key schedule changes and providing a framework that lets us use all of these key schedule changes in a consistent, secure, and composable, most importantly, composable way. So this is the TLS key schedule, truncated at master secret. And we're proposing to inject at 2 and perhaps 3 points. We want to modify the way PSKs are used such that we can do fancy things, and we want to inject an extra secret before the Diffie-Hellman. Kartik suggested that we could also inject just before master secret, but that's for discussion. So the zeros are actually non-trivial. The 2 zeros aren't the same, even though they look the same. The top 0 is a salt and actually just says, we assume that PSKs are uniformly random. And the...
I understand that point. I'm talking at the bottom 0.
So you're then using the HKDF as a dual PRF, and because you're injecting 2 secrets and you're assuming that both of them get the same property.
No, hang on. Wait a second. Ignore the top.
The bottom 0.
Bottom 0, like everywhere else in this key schedule, the thing that comes from the left is the what IPK, right? The initial random IKM, and the thing that comes to the top is the salt, right? Mm-hmm. So and if you just scroll up one HKDF extract above, you're extracting the DHE secret. And so I'm saying when you want to do I don't understand why you can't put a IKM on that 0 slot at the bottom.
So okay. So if you want to inject stuff before the handshake secret, you then have to do something with DHE.
No, I agree with that. The first 2 points, the points that are shaded green, I agree with you.
Oh, yeah, okay.
I'm saying that this last point, the one that's shaded white, that's called the thing that's 0 there.
So that also, you could also do that, but the question then is, do we want to do this in a consistent way? And just always do the same thing?
Okay.
So Martin Thompson, I would say that the consistent way is to change the thing on the left. But we've had this discussion.
Mm-hmm. Wait till my last slide.
Exactly. But that's the approach taken by the semi-static thing with that 0 in particular, which is what Eka got up to object to. The PSK importer stuff does that with the PSK right there, but
it does it in a different way.
It doesn't. It really does, doesn't it? And that's curious. We should
Wait 2
probably
slides.
do something with that. And ECDHE is another one that I'd like to have a look at as well.
Wait till my last slide. Okay, so just to point out that there's a bit of syntactic sugar. We've got HKDF extract and derived secret. Derived secret is syntactic sugar for an HKDF expand. Just FYI. Okay, TLS uses an HKDF, and it has extract, expand. Extract takes non-uniform randomness and makes uniform randomness. Expand takes uniform randomness and makes cryptographically unrelated keys. Okay. So this is the change we're planning to make to the PSK extension. All we do is add a context field and then use that as the ID instead. And you can do that recursively. So you might want to say add 3 or 4 PSKs in a chain, and just each one comes with a context, and you just compress more and more of that into the PSK ID. The context is not necessarily secret, but should be non-guessable. it should probably be a channel binding if you're doing anything complicated, but I sort of leave that to implementers. If you're going to do something complicated, do something complicated. Okay, so what does this change give us? You can bind extra information into the handshake. So I can bind non-secret information to the handshake, and this is analogous to the TLS exporter interface. So in the same way that I can layer something on top of TLS, this lets me layer TLS on top of something else. And that's where you would effectively end up with channel bindings. And this sort of just harmonizes the sort of structure that we should have done in the first place. And I don't think it affects the security proofs, and we shouldn't have to do anything fancy.
Well, I'm not going to feed your trolling there about what we should have in the first place, but I just want to have a question. One might this at least one might reason about as injecting into the transcript instead of injecting into the key schedule, right?
Mm-hmm.
Okay, just want to make sure. If we had every message had a extra like a notional here's extra crap that could fold in the transcript, that would be the same as this, right?
I think so.
Okay. Because I know the other stuff doesn't. The post-quantum stuff is new secret entropy, but
yeah.
this is just new stuff in the transcript. Okay.
Yeah, this is just saying here is a place to inject what I think should be channel bindings, but effectively whatever.
Martin Thompson, can you go back one slide? How is this different to the importer things?
It's not. This is document bashing. I think it should be moved here.
Yeah.
It's basically a copy.
Yeah.
And there's an extra label.
That one's going to working group last call. I don't think we can do that. You might want to use this document to rationalize that, but I would not change the structure of what's already been agreed there.
Okay.
Daniel Kahn-Gilmore. I don't think this is exactly the same as putting stuff into the transcript, what Ecker said earlier. In particular, if you stuff arbitrary stuff to the transcript, it might look the same as stuff that might already have been in the transcript. And this case is strictly additive.
Yes, so that's why you have to use a different binder label. If you look on the bottom right, there's impex binder and imprez binder. Basically, if you're doing an out-of-band PSK, use impex binder as your label. We might need to shorten that. And basically, that says you can't confuse an out-of-band PSK using this and an out-of-band PSK not using this.
Oh yeah, I'm sorry. My hypo was it was injective, right? My hypo was we'd have a faked handshake message that was additional crap in the transcript, and we put it in there, and that I think would have the same properties as this in my head. And if it doesn't, then I want to reason about it. In the same way we did with the re-injection for CH1. I hope so, because otherwise I'm not reasoning about this correctly, and that concerns me. But I'm not saying I have a problem with this technically. I'm just trying to make sure I understand what it's doing.
Yeah, the labels are important, but yeah. Okay. Oh, did I finish this slide? Oh, yeah. The reasoning why it shouldn't affect the security proofs is we're doing an HKDF expand, and we assume that HKDF expand gives us disjoint key spaces or computationally disjointed key spaces. Okay. The second piece is here. You have an extra derived secret and an extra HKDF extract, which is an extra expand extract. And the idea is that this will isolate the injected material from the rest of the handshake. And the inputs are injected in a fixed order. We'll have an IANA registry that says, this goes first, this goes second, this goes third. Okay. So what does this give us? It's not the same. It allows us to add new secrets to the handshake. Before we could only commit to new public values in the handshake. So we could do encrypted client hello extensions, or we can add quantum safe secrets without giving up any classical crypto. Hugo pointed out that if there's no PSK and there's a weak Diffie-Hellman key, then a malicious input may be able to bias the handshake secret. But if all your secrets are weak or controlled by the attacker, do we really care? If we do really care, we can use this design. So this basically just uses the dual PRF property of HKDFs, and we inject, this is copied from Draft Stabila and labels combining KDF1, and basically we extract from the ECDHE and the, well, in this case, next gen would be quantum safe, but we'd replace that with just anything. Downsides to this, the key schedule is no longer linear, and also we can't necessarily repeat this. We wouldn't be doing the same thing lower down, although I guess we could if you want to.
So, Martin Thompson, Draft Stabila covers a number of options that look approximately like this, or like the one that you're proposing.
Yes. I'm proposing that we do one of them.
Yeah, and I would also propose neither of the two options you've presented on the screen.
Okay.
So,
see if our condition's the same.
Yeah, I'm perfectly comfortable with taking all of the inputs that we have at a given point in the key schedule and combining them in some fashion. I don't think we need HKDF extract for that. We just need a mapping that is clear and
We try to serialize them.
bijective. You just concatenate them in the simple case, because most of these things are fixed length. But if they're not fixed length, we put length prefixes on, and everything's gravy. The reason that I say that is that we have, in most implementations, all the necessary machinery in order to switch out the thing that appears on that left-hand side input to HKDF extract. And building on top of that machinery allows us to effectively reuse an existing joint that we have in the protocol, rather than invent new ones and extend the key schedule in the way that you proposed. And I do think that Hugo's concern is valid, because there are cases, if the construction of HKDF extract as a dual PRF is not as strong in the direction coming down the chain as coming in from the side, then, well, maybe we have problems with PSKs on their own, but I would rather have it come in the side.
Okay.
Yeah, I generally concur with Martin that basically, to the extent to which we think, so if you go back to, can I see your previous slide? Sorry, two up. I want to say that sucker. Yeah. So like, okay. So it's like I think that like if you sort of scroll back and to like acceptor trolling previously, what we should have done, right? You know, the annoying thing about the current TLS key schedule is that we basically only allow one secret at each of those insert points, right? And so like when you're trying to extend that, you're like, well, this one says now we have two. And it has the same annoying problem. And so does, and Doug's is like the same annoying problem as well, which only has two. And so like the, you know, the original sin here is like our failure to like allow an arbitrary number of key values at each insert point. And so whatever we do, we should fix that. If we think it's good, we should fix that. And so like either we should do it by being like, you know, like, so either we should do it by being like, you can have an arbitrary number of things, you just extract. That's one possibility. And the other is you have a combiner and then you glue them in. I think the combiner and glue them in, like, obviously makes more sense. I'm willing to, like, you know, I being a caveman, also like naturally do what Martin says, which is like concatenate them with like length fields and treat it all as one giant thing. I'm more than happy to be told by some cryptographer that I'm a caveman and that like I should XOR them or I should do some other garbage. But like I leave that to like the crypto people. But I think what we should do is define an algorithm for saying take n secrets, crank them down to one, and entropy bottleneck it at the KDF, and then shove it in the left.
Yeah, sounds good.
Russ Housley, could you back up to the green box one?
1 second.
That
Yes.
one. Yes, thank you. So what basically Ecker said was if you look at this, if you combine all of the stuff, you can replace that 1 0 and get a result, except for the early data situation. And I couldn't tell whether he was proposing something that affected early data or not.
Sorry. My put is everywhere in this key schedule that we have a thing with an arrow on the right arrow at HKF extract. We define a new rule that if you have n things, you combine them with formula X, and then you replace, and then you shove it in. And I guess just to make life simple, if you have one, you can do it. You just shove it in. And then like our problem will be very simple, and in fact, I mean, so Martin's thing is nice because Martin's thing, like, actually you can define an encoding, which is exactly this property, and it's just a serialization. Now, if we're forced to and actually so is XOR, by the way. If we're forced to do some sort of like nonsense with like multiple HKDF stages, then that won't work. But yeah, my point is basically just take each of those HKDF extract joints and like redefine the symbol on the left.
Hannes, the line's cut after Hannes, and Hannes, please keep it brief. We're running out of time.
If you compare the schedule of 1.2 to 1.3, it became so much more complicated. And the argument back then was we need this because it simplifies the proofs, and that's great. But I think, listening to your presentation, we are making it incrementally more complicated. And I would wish that someone actually looks at how to simplify the proofs or to tailor the proofs a little bit so that we don't have to make this more and more complicated, because if you look at the code that we have today in 1.3, it's this part is actually one area where you have way more cryptographic operations that you need to do, way more code, and that also is there's side effects of that, right?
Yeah. So that's actually one of my further questions. Line cut?
Yeah, I mean it is. But...
Sorry. Do we want to extend the master secret? Should we just concatenate the injected secrets? Should we be worried about the number of new hash invocations? Yes. And how should we handle extension negotiation? So because this is crypto, you have to, if you're doing the PSKs, you have to send either just one PSK that says we are using these extensions, or you send a group of PSKs that say, I'm happy with any of these combinations, or you can send one PSK and rely on hello retry if the server's like, actually, I only want some of those, or I want to add some of your other, some other ones that you support. And the most important question is there interest in adoption?
To Russ Housley, I think this is very interesting, but I think it's also very complex. And the key schedule is the core to TLS 1.3. And so it looks like TLS 1.4 to me.
So just to answer that question, does that mean you think we should not do any of these?
No, it's very interesting and we should do it, but if we looked at it as a new version number, it would solve a bunch of those problems that you just listed.
So we should open TLS 1.4 now? That's a rechartering discussion.
It certainly would be. So let's take this to the list because there's some questions. And so, Daniel, if you want to throw it in, but like keep it really quick.
Okay, so I just want to emphasize that it represents a major change. So we have to be careful and not to rush that.
Yeah.
All right, thank you. Some wonderful green charts. It's not going to stand.
These slides are designed to ensure that you pay attention. You know, Martin and I had pretty walked in a contest to make the most offensive possible looking slides. I think. Maybe. High-vis orange next.
David Skenazy, Google. May I offer a slight suggestion that the two of you can take your rivalry about making really bad slides somewhere else? But yes, please keep going.
Okay, so this is some work done by me, Richard Barnes, and Hannes. Yes. C. I guess the fact that I never actually name what it is. C is compact, by the way. That's why the C is lowercase. So okay, what problems are we trying to solve? Despite like the the fact that everyone's like really thrilled with how 1.3 turned out, Jonathan especially, things are not perfect. There's still some annoying like legacy cruft the TLS handshake, especially in like the client hellos. The fields are like labeled legacy can't be changed. Those are awesome. Now, like unfortunately, like in many contexts, we're just like stuck with that because like welcome to the web and like you can never send anything different ever. But like maybe that's not something you have to live with forever. And it's like particularly like we did quick, it was kind of silly to like we have these quick messages that contain like legacy like version numbers that nobody uses. Second, even from the beginning of 1.3, there was sadness about the sort of rich feature set. And that has a number of problems sometimes. One is it made it hard to do like, say I don't want 0RTT and I don't even want resumption and I like how do you define like what the minimal feature set that like maybe easier to implement is and maybe easier to reason about is. And second, obviously, it makes the constrained up makes the implementation size bigger, and the joints that you need to make it work also make the protocol on the wire bigger. So, like in particular, like if you only have one key share, like why do you have like a bunch of extra values telling you how many key shares you could have? And if you only have for one key share, like why do you need HRR? And if you only for one key share, like why do you need some way to like say these are the named groups I support because those are all the same stinking thing. So finally, there is a separation in 1.3 between the handshake and the record layer, but it's not like quite as clean as you might have hoped. And so like, and you see that like, it looked fine when we did 1.3, but then when we tried to do quick, it was like obvious that like maybe that was not like quite as clean a set of cuts as you wanted. So quick is really like TLS 1.3, like handshake with a quick record layer. And that like, like that worked, but like, it's like the document is like, take these parts of TLS and like throw away these other parts of TLS. And so trying to cut that out would be nice. This is also an issue if you look at like Lake and when you might think of OS core as your record layer. So in general, like it's from a pedagogical perspective, it's like much easier to interpret if you think of it as one protocol, but from a pluggable perspective, it's maybe not. I think Christian Wiedemann made this point actually quite a while back. I think Paul Baker did as well. So a number of these issues like were known, but were kind of punted out of 1.3 either because like being done as a feature, and they didn't really affect 1.3 itself, or because we couldn't change them, like as in the case of the legacy cruft. We always knew we could like do like a reduced profile, but like we were too lazy. I think Watson Ladd talked about doing like a TLS 1.3 light at one point, but never got done. Now we thought we might try to actually solve some of these. So there's a bunch of motivating use cases for this work. One is quick, as I was indicating. Another is ATLS. Is that what you called it? Is it ATLS? Is that okay? So like the Google thing has some other name, like ALTS or something. There's a Lake for having constrained sizes, and there's EAP as well, where also has been an issue to have like really large message sizes. And anytime you try to map, it's also kind of an issue for DTLS. Not as much, but kind of one. So to say that there's a bunch, and again, in ATLS, you might think about maybe you don't need the record layer, for instance, and Lake the same way. So there's like 2.5 technical pieces here, which we might adopt some or all of, or none of, for that matter. So one is some cleanup on the handshake messages to make them like less like kind of gross and crufty. I'll talk about each of these in detail. The second is this kind of like vaguely advanced specialization mechanism for describing subsets of TLS, like in a way that isn't just writing new document profiles. Finally, more clearly delineate the handshake and the record cut, so you know exactly where to cut. This last piece, as I say, actually doesn't really appear in the spec, but I'm pitching it now, and it's not quite clear from a spec mechanic way how we do it, because what you really like is like to sort of go back and rewrite 8446, but in practice you probably want to write a meta document which says these are the pieces you would need and these are the cut points, and in particular this is what you like depend on or not. So okay, let me start with the first point. So cleaning up the handshake messages. Basically, so like I think we can, like, in retrospect, agree that, like, maybe the encoding on the TLS, like, wire encoding is not amazing. So in particular, like, there are lots of places where they're like integers which are like way too large for their like intended uses or way too small for their intended uses. And so, like, either chewing up space in the wire for no good reason, or contrary-wise, contrary-wise, you're like, hey, I can't fit. And also, like, if you look at like everybody's implementation, they all have, like, for every time you have to encode an integer, like, the functions for encoding and decoding integers all come with like some number that tells you how big the integer is. And that's, like, really amazingly awesome. If you like do this, so if you do this in C, you like have like decode uint x, and like there's a field that says how big it is. If you do it in C++, you like start thinking you use function overloading and like time flight specialization, and like that does work, except then there's no uint 24, and so things don't work out so well. So it's like not great. So, like, replace every integer with a variant is, like, actually makes life substantially easier. It also means that, like, you don't have these goofy situations where you're like trying to decide, like I can't tell you how many arguments I've been where we're arguing about, like, should, like, the maximum length of this field be 65,000 like objects or bytes, or like 255 bytes. So, like, that makes all this go away, which, like, is it increases load on us. So removing some unnecessary legacy fields, like, as I say, these veiled fields which, like, only exist to make 1.3 look like 1.2. Session ID is a good example of that. Also, Richard Barnes suggested removing the handshake message length from the handshake framing, and just saying, look, the handshake messages, like, all are self-describing in terms of length, so there's no way to get confused. This is actually quite a point of confusion in your implementations where, like, you have to, like, think about that. So one difficulty here is backward compatibility. Obviously, you wouldn't be able to emit a client hello, like, according to these rules. It was parsable by existing implementation. So I think what you probably have to do realistically is you would do this, but then you'd say, like, hey, you'd also have to be like, if you don't know what the server does, you have to be able to emit the old client hello as well and receive it. The server hello, I'm sure we can find some way to make it obvious, so they'll only have to change the first message. So this is, like, semantically identical, right? This is just like what you might have thought of if, like, you, like, had a different kind of design philosophy when SSL v3 was designed, like, 25 years ago. Because we're just inheriting the structures from v3, right? This would be like a non-trivial simplification, at least in my implementation. I suspect in others. Next slide. Oh, on the next slide. So like, that's a simple piece, right? The sort of fancy piece is, like I said, TLS is this, like, generalized protocol. So, like, you can do, like, an enormous number of things, and you get all these joints to let you negotiate every possible thing. And that's good in the sense, like, you get a very powerful object, and you get a very powerful object, and in particular, we have, like, an analysis of the entire thing. And so we can tell you, like, we have an opportunity to tell you this is, like, this whole security profile of TLS. But, like, with that said, maybe you don't want all that stuff. So like, why are you paying for that, both in the wire and in your implementation? And so the idea we had, actually due to Karthik Bhargavan, is to I'm going to steal a term from Rust, monomorphize. So you have like a generic system which is polymorphic, and what you do is you monomorphize it. So you take a given axis of flexibility, say the version number, and you say, well, in principle, like, the system supported, like, 1.3 and 1.4 and 1.2, but we're going to monomorphize it down to 1.1, and so all 1.3, and so all the code you need, like process version negotiations, just go away, and all the wire machinery you need to process version negotiation goes away. And so and the idea here is you can, like, independently monomorphize in every axis, and here's the cool part that Karthik suggested, which is you reconstruct the transcript as if you had not specialized, and so you get the same wire transcript as you otherwise. You get the same thing in the key schedule as you otherwise would have. So you can just think of it as a piece of compression. So I've italicized my term. So we have monomorphize and reconstruct. I thought you'd appreciate that. So the key idea here is you get specialization, but you also get forward compatibility. So we, like, remove extensions you don't need because you're not using them. But if there are new extensions you need, they just work fine. And so as an example, we can so otherwise unknown extensions just work fine in the future. Also get to known certificates, the certificates point. But as a general point, this gives you also a way to compress certificates, but a way to also deal with certificates you never heard of. So one way of thinking about this, I think also due to Karthik, is that this is like a compression layer between the handshake and the record layer. And so on like emission, you compress using the profile as input to tell you what to compress out, and on parsing, you decompress using the profile as input to tell you how to decompress. DKG is loving this, I can tell. This is like a lot simpler than it sounds. Barnes has a like really compact implementation of this in Mint. So the specializations themselves are, this was supposed to be hidden. I apologize. I did mark it hidden. Specializations themselves are like basically defined in JSON. So here's like a simple specialization. This says like do only TLS 1.3 and do only these the cipher suite. And so when you do this, you just don't put those things in the wire. They just don't appear. So you just save yourself what, like, I don't know, like 8 octets. So like that was some. But again, and so when you decompress the transcript, you have only the fields as if like those are the only things supported. So that means you have a one version in the version supported versions list, and you have on both directions, and you have one cipher suite in each direction as well.
Martin Thompson, question for clarification, more for other people to understand what's going on here. You're going to signal which one of these profiles is available on the wire, or assume that there's something available in the context that defines that.
Yes, quite so. And so the nonsense previously, the thought I admitted was you might imagine actually having a way to signal on the wire that actually was like injective, and you could figure out what was going on, but as opposed to registration. Okay. We have a whole bunch of points you can axes you can monomorphize on. It's worth dealing with extensions because that's probably the most complicated one and the source of most of the actual size of TLS 1.3. So we have this idea called predefined extensions, and basically the idea is you say this extension only has this value. So like here's only AOPN value, and you just basically spit out a fixed text string and you stuff it in the profile. The extensions do appear in the transcript, as I say. This allows you to have other extensions which are encoded as usual, which aren't the ones that are predefined. So it's just pop in normally, and in order to make the decompression work properly and the compression work properly, we require the extensions to appear in copoint order, which is a change from 1.3, but it's a compatible change. Namely, you're always allowed to do this except for PSK, and PSK just has to be at the end. If I recall, crypto had this property too, though it didn't have PSK. Now we have a few places where there are axes, they're sort of non-orthogonal axes that we've defined that I don't think appears here. That don't just involve predefined. So as a given example, like if you say, well, I only do curve 25519, that like has implications on a bunch of things, but it's one axis of monomorphization. So here's like a good example. This is like a sort of highly compressed profile. So you can see this in a version, it has one cipher suite. There's this DH group parameter, which means I only support 25519, which means I'm not going to send supported groups, and I'm only going to send one key share. And like, by the way, don't do HR because that doesn't make any sense. This has like reduced random and finish sizes to give you a highly compact thing. This is going back to the Lake use case. And then here are the extensions. So that's SNI and that and their signature algorithms as well for certificate request. So this also implies you're going to do mutual TLS authentication. So this is sort of like both in the notational convenience, but also you might imagine having a machine readable implementation which could process this and then either enforce this automatically or actually, to go back to the sort of extended Rust example, really monomorphize, where like I have an implementation which is really a meta implementation. It processes this and it spits out a straight line implementation which only does these things. And the idea is, in that case, what you do is you just like pickle the strings into your implementation directly. One special point which is worth getting at, which is this known certificates. So like in any real situation, where a vast majority of the data on the wire is the certificates themselves, so you need some way to compress them. There's some nice work by I think I'm trying to remember who did this work now. Who's in the name of this? Some people about compressing certificates generically using like compression algorithms, but you can do much better if you actually know what the certificates are. And so Richard had this great idea of you basically have a map of the certificates, which is just the flat out certificates and a nickname for them. And then you literally just encode the nickname in the certificate entry field as if it was a certificate. And as long as you make sure that like you can distinguish them from certs, then it's not a problem. So like don't have them begin with OX30 or have them be like really short. And then these get blown up in the transcript like everything else. That's actually a really important point, because you don't want to have like very short names that don't appear in the transcript, because that creates confusion about in the transcript about who you're talking to. So like UKS type attacks. So this is like very straightforward, but it works nicely. It's kind of analogous. It's kind of like a specialized version of cached info. This gets you an enormous amount of compression. If you do all this stuff with a profile I just showed you, basically you like reduce the size of TLS by like a factor of 3 to 4. So like that's a pretty good amount of reduction. A lot of that, to be honest, is due to the certificate, but not all of it. This is something obviously we've been working a little bit. We have a draft implementation in Mint. Yes, sir. You might as well come to the front anyway. It's boring back there.
Chris Anasio, Carnegie Mellon. So the compression you're showing here is actually bytes on wire, nothing to do with code.
Bytes on wire. Yeah. Those 21 bytes of code. This is the bytes. This is the bytes on the wire. And so basically, what these overhead numbers mean is like there's some basic amount of data which you like need to have in order to like make it work at all. Like the crypto variables have to be given fixed size, and the overhead is like how much more we are over like the minimum fixed size you had to have. So like you can't have Diffie-Hellman without like carrying your 255 keys around, and so like that means a minimum size of the handshake is relatively large. So this is all about reducing things above that. So like just let me open with like I understand that like this specialization thing looks a little fancy, and we're sort of back and forth on like how overwrought it is, and maybe a little overwrought. So definitely feedback desired on like maybe we got too fancy in pieces of it. But it actually worked out pretty well, and I think it's a good way to define sort of these minimal profiles, as I say, both for compaction and also for implementation want to be simple. At the sort of the cost of the simple implementations of having a bunch of like fixed strings floating around the system. Right. So the final thing is this handshake record layer separation. I'd say this doesn't really appear in the draft very much. There's some hand waving about it. Nominally we like actually had a handshake and a record layer, but actually, and like the security proofs of TLS like actually don't really depend on like the record layer at all, at least for the handshake. But nevertheless, like the record layer is like glued in there. Quick separated them, but like not like in any. Let me phrase this carefully. Not in an unprincipled way from a document perspective, but in a fine way from a technical perspective. And the reason from the document perspective is we had given them no hooks to do this with. And so the proposal here is to actually do the document engineering that describes, this is where the cut point is. This is the expectations TLS has about the record layer. This is the points at which the keys get emitted. This is what you can do here, here, and here. And that basically this drives an abstract interface between the record layer and the handshake layer. So, I mean, as I say here, this is really retconning what we did in Quick. But the idea is if you wanted like another thing like that, like say for OS Core, that it would then be straightforward because you know exactly what the interface points were. So, I don't know if anybody read this. Okay, I see some people raising their hands. I mean, these are your questions, not mine. But the
question really is, right, so where this would go. The ADs directed us that basically if it was going to get adopted anywhere, it was going to get adopted in this working group. So this is a request. But we can only really adopt this after we change the charter. So if I'm going to take this hum because I want to do this, it's obviously modular on the fact that we can get an agreement on the charter. Daniel.
So Daniel Migo Erickson. I think it's not the first time we are compressing protocol. It's a well-known thing. The IETF got a lot of experience in that. And the LP1 working group has been focused on that, and they've defined a framework. I think we should work with them and try to be as close as to reuse the concept, at least they mentioned and use the same syntax, at least to express the compression. So I think we should work with them.
I'm not familiar with that work, but I'm happy to take a look.
Richard, you're going to have to come forward. That mic's not working. I'm also going to cut the line.
Yeah, I think certainly like this is like v like -1. Yeah. So like if the working group wants to work on this and like go in this general direction, like I think we'd have like a lot of like room to like screw around with what the actual syntax was, because like this was like made up by me like in 2 hours over a beer.
David Skenazy, quick enthusiast. Just first off, clarifying question. You mentioned Quick as a use case. Just to state what I think is the obvious, but to double check, you're not suggesting this for Quick V1. You're suggesting it for a future version, right?
I think what I'm suggesting is that the yes, and as they say, what I'm suggesting is that this piece here would retcon what we did in Quick. So it would just match, wouldn't create a dependency in Quick, but would match what we did in Quick. And that then if we did cool things, that they might get adopted in Quick V2.
Cool. In that case, I just wanted to say that I like this. I'm really supportive, and I would like to see it move forward in this working group. And if that means a recharter, then that sounds fine to me.
Valery Smyslov, Alice Plus. I think it's an important work, and I think that TLS working group should work on it. But I have one clarifying question. So it seems that profiles are distributed out of band, and client and server must have exactly the same profile to be compatible. And what will you do in case the profile need to be changed? For example, a new extension is added, or I don't know, something is removed. For how will you solve the problem of simultaneously change profile for client and server without any disruption of the service? So I think this problem should be solved.
I agree. I have some ideas. They're probably even too half-baked to make up at the microphone, but I agree it's a real problem.
Tommy Polly, Apple. I think this is very good work. I'd love to see it adopted here. Also working on Quick, I think it would make a lot of sense to streamline things. But to the point that like Daniel was making earlier, I mean, yes, we have a lot of other things that do compression, but I kind of see this having other benefits besides just making the handshake smaller and giving compression. It's not merely that, because I also see a lot of trends in people doing kind of like new application cases in which people look away from TLS because they're like, oh, it's too complex, it's too extensible, or these other things. So I think this will also make TLS more attractive to people looking for these lightweight use cases, and that's a really big benefit in my mind.
Yeah, that's certainly something we've been thinking about, and I think that's been sort of a point where Richard and I have been going back and forth a little bit, in that there's like syntactic compression mechanisms you can use, and there's semantic compression mechanisms you can use, and I've been definitely leaning more towards semantic in many cases, at the cost of some syntactic complexity. So I think that's the part where where we have to think about like, is what's the most optimal mix of those. And I think there's going to be some, I mean, you can see even here, there's some, like there's some pieces which are basically syntactic, which is like replace this extension with this like string. And there's some pieces which are semantic, which is like we only do this Diffie-Hellman group. And trying to find the right mix of that is going to be difficult.
Daniel, I cut the line.
Dmitry Belevsky, Technical Center of Internet. Do we really have serious advantages because of switching from the fixed length integer to variable length integer? Thank you.
It is not enormous. You get probably, I mean, when I looked at this, I think we got like, of our basic TLS handshake, we probably shaved off like 30 or 40 octets, so it wasn't like enormous. It was partly like, so like I'm not fixated on keeping that. It's just like I felt like doing any kind of work here and not cleaning up some of those gross points bothered me a little bit, but like I'm not going to go lie down on the road over it.
All right, so I'm going to take two hums, and then we're going to take it to the list. So the first hum is whether we want to adopt it as a working group item. One is whether we do not want to adopt it as a working group item. So please hum. If you would like to adopt this as a working group item, please hum now. If you do not want to adopt this as a working group item, please hum now. The yays have it. Again, we'll take this to the mailing list. I will note that it was silence on the no. Very soft. Oh, I definitely. Great. Are you next? All right, Chris, you're up. Yeah. So I've gotten multiple complaints up here about the slide color selection. So going forward, we'll try to be a little better. Oh yeah. So I mean, if somebody did want to say no and get to the microphone, feel free to explain.
Great.
Ted, are you taking the vantage?
Ted Hardy, it was really no and, which is the unusual variation of yes and. I actually think all of the work is interesting, but that it should be decomposed. The retconning, for example, I think is going to be much faster and very, very useful quickly. Where some of the compression stuff, there's lots of different ways you can approach this, and that if you split the work up, it might be significantly faster to get some pieces of it done. That's not a no to the work. In other words, it's no to this particular cluster being all one thing at the end of the day. But I'm fine with the answer being yes after the hums are taken. It's a very tiny place in the rough to be in.
I'm also happy to defer to the wisdom of the chairs and ADs and the working group on like how to cut these pieces up.
Great. All right. So this is the semi-static Diffie-Hellman draft that I was alluding to earlier. We have talked about this previously in London. Nick gave the presentation. Draft has been sort of revved a couple times since then. Not much changes, but given the renewed interest in compact TLS and how this helps, we figured we'd bring it back to the working group and see if there's interest. So for those of you that are not familiar, the semi-static Diffie-Hellman is basically plugging a hole in the OP-TLS design that was not yet filled by TLS 1.3, which supports the normal 1RTT case, non-semi-static, where the server actually gives you a certificate instead of a Diffie-Hellman key share, and then both PSK variants. So the semi-static case is instead of the server sending a cert and a signature computed over basically the handshake transcript, you get a static Diffie-Hellman key share, either in a delegated credential or via carrier pigeon or something else. Mix that into the key schedule and then replace the certificate verify, which is typically a signature, with a MAC, and presumably everything else will sort of fall into place. This is sort of what that looks like if you think of it in the OP-TLS flow. So client hello goes out the door, server hello comes back. You get both a Diffie-Hellman key share and ephemeral one, which is G to the Y here, and in addition to that, a semi-static key, which is typically represented as G to the S. And then the rest of the computation is sort of the same. Instead of a signature, there's a MAC. Great. And the motivation for this is, I guess there are a couple points that we want to highlight. The first of which is there may be scenarios where you only want to use a single primitive. You might not want to use signatures at all. Like you can imagine, clients and servers supporting semi-static Diffie-Hellman. Clients would only need to, support, like have code to do Diffie-Hellman operations. They wouldn't have to do any signature verifications, assuming that the server did not deliver, the semi-static key share via certificate or anything like that. And potentially also that the client is like pinning the Diffie-Hellman, the static share that the server gets, so it knows like which thing to use and doesn't have to basically punts the authentication of the semi-static share in that context. And in the web, where a semi-static key share is delivered by a delegated credential, you still have to do a signature verification on the certificate. This just allows you to potentially do different algorithms like the ones that Nick was referring to earlier. It also has benefits in that it's potentially a lighter key exchange variant, not in the certificate case, but in this sort of deployment model where you have only Diffie-Hellman, using semi-static instead of massive signatures or massive certificates and signatures is potentially more appealing in those contexts. Also has the benefit of explicitly missing a long-term secret, which is the static share, into the master secret. Of course, there are other ways to go about sort of mixing things into the master secret, or like potentially helping with bad randomness or something like that. There's a draft in the CFRG which kind of talks about something different, or a different proposal, but this is, this has that consequence. So that's nice. The idea is basically to this is the current TLS 1.3 key schedule, wherein the master secret is derived. You'll notice that there's this nice convenient little 0 on the left that Jonathan was actually referring or covering earlier in his presentation. The change with the semi-static key schedule is basically to take the output of the client ephemeral and server static and put it in that slot, more or less, and then compute a MAC with that secret. How convenient that we have that 0 there. To negotiate this thing, there will be a extension of, or addition to the signature scheme enumeration that says I support signatures with P2P6 or whatever the name group you want, and if the server supports it, it would just send back either a delegated credential if you also supported delegated credentials or whatever mechanism. I think the actual details of how we get the keys delivered to the client and potentially something we can work out. I'm sure there are many ways we can paint that bike shed. Yeah.
Yeah, Martin Thompson, I know this is just a spelling exercise, but I'm wondering whether the scope of the changes you have here are appropriate for doing something in signature algorithms rather than, for instance, having a new extension to signal these things and even potentially a new message that you would send in replacement for certificate verify, for instance.
So I'll go forward one point. One of the open questions is whether or not we just drop the certificate verify entirely, and just rely on the AAD kind of giving us that confirmation. So yes, that's potentially one option, a new extension to negotiate it, a new message to certificate verify, potentially this.
I think I'm a little more comfortable with making this a new extension. I'm not sure that I know how to make the decision about certificate verify and finished here. It seems like finished might work, but I'm uncomfortable with that. But
yes, that certainly needs more analysis. The nice sort of appealing property is it makes it more of like a noise-like protocol where you don't have like explicit things giving you confirmation, or just like folded into the key schedule as you go forward. Yeah, Becker.
Yeah. So I think in pieces, right? So I think the reason we did it this way, that the design where we're like is indicating is signature algorithms is like that's the purpose, that is the function that you're serving, right? So, it is verifying the certificate, it is binding the certificate to the transcript, to the transcript you're sending. It's just a MAC. In fact, if you will notice, like Jose and Jose refer to these things as signatures, I believe, very often, which I don't like any more than you do. But it is definitely, it's not a signature, but it's a certificate verify. This question about certificate verify versus finished, this turns out to be a philosophical problem. And if Hugo Kruchek were here, what he would tell you is that the reason why you have to have certificate verify is because you are using the long-term Diffie-Hellman key to authenticate the short-term Diffie-Hellman key, and that means that that means that you have to have a and so there's this question about circular dependencies between those two, and so finished uses both of them, and so the idea with certificate verify, what you want to have is you want to have a MAC that is solely composed of G to the X and G to the S over the rest of the transcript. And so I thought that's what the spec said, but it was a while ago I wrote it.
It does, yeah.
Yeah, and the purpose of finished is to provide liveness liveness and verification of all of both keys, right? And so you can imagine removing the finished in TLS ordinarily, but then you lose the property. The property, the CK property, which is the handshake alone without any reference to the record layer, guarantees completion of the handshake and the properties. So I think you do. You could say I don't care about the circular dependency, and I sort of like when Hugo told me this, I was kind of like I'm like a caveman, so like whatever. But like it seemed important, and I'm gonna. This is a situation I'm kind of deferring to cryptographers who told me that like the circular dependency issue is important.
So just to clarify my point. I was more worried about this extending to changes in the protocol that were more than just confined to the signature negotiation and construction, because the insertion into the key schedule is a new thing that some implementations maybe you're prepared to do if you do that solely inside the certificate thing.
I see. Yes. So I guess I would say that like can we go to Chris's benefits? Your benefit list. Yes. So, I mean, we could simply say we don't care if this lost benefit, right? And then you could build a system which is isomorphic to 1.3, which really just use max instead of signatures, and would actually be like a perfectly fine protocol, right? I guess later on, Chris, I think Chris talks about client authentication, and so in the current client authentication mode, we do not in fact mix them, and so it's a little goofy, honestly. And so like I would not actually. I think Karthik was pushing for basically keeping the current TLS like structure and not using that last joint in the protocol. So I think that would be a totally valid thing to do. It would be. I am like different people have different. I mean, I guess you weren't in the lake yesterday, but different people have different levels of sympathy for this position at the long-term versus short-term secrets. I have like not a huge amount of sympathy because I generally figure they're sitting in the same memory locations. But if you have the usual rationale is that you have like the long-term secret in some like special box somewhere.
Two quick points. Is it obvious that this gives you the same guarantees or equivalent guarantees as TLS 1.3 in its ordinary mode?
The authentication properties are slightly different.
Yeah,
It's obvious, but might be false. I believe that's the case, and I think Karthik did a little modeling of it, but I think like that would TBD, right? Sorry, it is in. I believe it does, but yes, it may be false.
Is the intended design that it does? Yeah.
Can we make this quick?
Yeah, we can just do it separately.
And second thing, this is a draft that is modifying the key schedule, and we should do that in a consistent way.
How convenient.
Cheap plug.
So there's also an open question of how we want to do client authentication. The draft has one particular approach. Maybe that's not the one we go with. There is an entire open question about whether or not you use the semi-static share for 0RTT and how you actually deal with early data instead of like using tickets to potentially anonymize like early data encryption to a server, and how you get that semi-static key in those particular scenarios. And there's an open question about how and when you can reuse a semi-static Diffie-Hellman key share, particularly when you're dealing with post-quantum stuff, which is not always safe to use the key more than once. So explicitly considering that we have compact TLS going on and there's interest in this particular work, and this has benefits relevant to that, I'd like to know if the working group is interested in adopting this and moving it forward. Of course, there are a lot of holes to plug and things to work on, but I think we can sort them out, especially in cooperation with Hugo and Karthik and folks like that going forward. So I will turn.
Yeah, so I think we'd like to get a sense of the room. So we'll have Haman first. Is this working group interested? If people interested in pursuing this topic, yes and no. So Ham, if you're interested in pursuing this topic. Ham, if you think the working group should not pursue this topic. Okay. Does somebody want to get up and voice their discontent? How many folks are willing to review this draft? About 10. Are folks willing to contribute text? About 5. Yeah.
Great. So we'll take that to the list to verify working group consensus for adoption, and we'll kick that off. David Benjamin, you're up next. We gave you 15, so technically you get 11.
Great. Okay. Also, I'm not very tall. Hi. Yeah. So problems always get better when you throw more cultures at them. So, like, why don't we do that? Oh, there's a screen over there. Okay. Excellent. Yeah, so if we look at TLS handshake costs, we've got like various symmetric junk, which is basically free as far as we're concerned compared to the other stuff. Client and server will each do an ECDH operation, which is much slower than the symmetric stuff, but we can negotiate a fast EC curve, and that's pretty independent of like other things. And then you've got like a signature with a long-lived key, which can get kind of expensive in some scenarios. For instance, if you're a hosting provider, the customer maybe provided you an RSA key, so you don't get to use any nicer like elliptic curve algorithm. Also, it's a long-lived secret, so you may apply various things to be less paranoid about them. Maybe you like RPC to some remote thing, maybe you stick it in some hardware thing, and these things make them more expensive. And so can we lower the signature costs? So the proposal is you go combine a bunch of concurrent batch signatures into a Merkle tree, sign one thing, and then that will cover exponentially many clients, and that way we can amortize the cost of things. Yeah, the structure is fairly boring. You have you can like either hash a leaf or hash two nodes together, and then the signature is a path. This is more useful with a picture. So if you have, say, 3 clients come in at once and your signing thread wakes up and you're like, oh, okay, I need to go make a signature. They build a Merkle tree on top of this. I'll talk about what the weird blinder nodes are later. Sign the signature, sign the root, and then you ship a path, or rather the nodes to the side of the path to each client. And this costs only logarithmically many. Okay, this is not very coherent slides after all. To verify, you do the usual Merkle tree verification thing. You recompute the root hash by hashing the path nodes up. So in this picture, you would start from input 2, go compute the hash up there, pick the bottom node in the path, recompute the next level, pick the next node in the path, recompute the level after that until you get up to the root, and then now hopefully that value matched, and you'll find out, because if not, the signature in the that you got chipped will not verify. Yeah, that's fairly boring. The draft so in order to advertise, we define some new signature scheme code points, which say do the normal signature thing, but also this thing. And as a result, we can now amortize our signature costs. While the signing thread or whatever is busy, you're presumably going to be queuing up inputs. Next time it wakes up, rather than picking up the next input, it picks them all up and signs them all at once. And at the cost of logarithmically many hashes added to the signature size, you can increase your signing capacity by 2 to the n. And so for a few hundred bytes, you get 100 or 1,000 or 1,000,000 x in signing capacity. So basically, you do not care about your signing throughput anymore at all. The TLS implementations need to be modified, but you can use the same certificate. You can use the same like signing RPC or whatever, because the only thing that changes as far as the signing machine is concerned is the input. We do require modified peers, and so presumably if you have a new deployment, you could say just require this and then care about the legacy case. If you have an existing deployment, then you can still get some benefits here because the average load will decrease if many peers support it. And underload when you're doing DDoS and have to decide which peers to which requests to throw away, you can preferentially serve the bashable ones since they're much cheaper. And I've been intentionally saying peers and everything because this applies symmetrically on client or server. Although usually the DOS concerns are on the server side. Some details. The domain separation of the inputs is preserved because we don't throw away the context string. The signature on the root has its own context string, so that can't be mixed up with non-batch signatures, since presumably your client your key is going to be servicing both kinds of clients. The blinding nodes, which may not actually be necessary, but since in ESNI the signing payload is secret, and if you look at the tree, the first node you would get is the sibling. The bottom node in the path would be the sibling. Would be the hash of a sibling in your tree. Then, in order to not have to think about it, we're like, well, we'll just pay one extra level of the tree to just put some randomness in there, and all the other nodes will have randomness merged in, so it doesn't actually leak the information. What else do we have? At some point, you need to go pad stuff if it's not a power of 2, so just copy them from other nodes in the tree levels, and then some information is revealed about signing loads. Sorry?
Speak more clearly.
Oh, yes, sorry. There are details on this slide. They're not super important. And there's a draft. Are there questions?
Hey, this is cool. Merkle trees are always fun. Daniel Kahn Gilmore. Eric was scroll up. Merkle trees. I was going to blind it. Merkle trees are always cool, obviously. Can you contrast this design against issuing just a DC with a very fast algorithm for this use case?
Yeah. So I think the main thing is that this will work with without the DC thing. You have to go build some infrastructure to go and deploy new DCs regularly. You need to deal with the DCs only work if the DCs are only useful if the lifetime is bounded by something relatively short, and so that means the verifier needs to have working clocks. But yes, it's true that if you do this and if you do DCs instead, then that will also get you some of the offsetting of things, because then you can punt some of the protections on the long-lived key that you would otherwise have had.
Okay. I'm generally supportive of this. I just wanted to hear from you that you thought this was worthwhile doing even if you had DCs.
Yeah,
in the protocol suite.
They're definitely addressing very similar scenarios. There are some scenarios that we're interested in where shipping short-lived certs for weird, apparently that's difficult for some reason.
Thank you.
All right. So we have 5 minutes left, so I'm clipping the line.
All right.
Martin Thompson, two brief things. I think you can avoid the extra full hash for the blinding. I think that was discussed briefly on the list, but
was it? I must have missed it, or maybe I forgot.
Yeah, we can talk about that later. And because this is so clearly orthogonal, did you consider minting a different type of certificate verify in order to avoid having to define an entire new access for the signature schemes?
I'm not sure I'm following.
If you were to signal this as a separate extension, and that caused you to generate a different certificate verify message that had all of the additional information in it, I think it would both be more efficient and possibly easier to manage long term.
So
think about it. Don't give me an answer right now because we don't have a lot of time.
So I did consider that. The main reason was just so that this puts slightly different constraints on the hash, and this way we didn't have to think about that.
Daniel Kahn Gilmore. I'm supportive of this work. You mentioned that it may leak some information about the server load. I don't think you need to do that. The signer can always sign a tree of arbitrary depth, and it's going to be cheap, especially when you're not under load, which is when you need to extend the size of the tree. So good. And thank you for including the binding. I think it's it's right to not want to have to think about that.
Rich Souls Akamai. Yeah, I support this stuff. You had me at when your signing thread falls behind.
Ben Schwartz, this seems like it could be good for slow post-quantum signing. Is that a consideration?
So my understanding is a lot of them are batched to begin with, but I haven't looked at that space too much. Maybe.
Okay, thanks.
Christian Utema. That's very cool work, but it kind of makes me sad. And the reason it makes me sad is that it makes the big servers more efficient. And thus it reinforces the advantage of the big servers over the small ones. And it pushes towards ever more concentration on the market in the internet. And that's what makes me sad.
So the big server, I guess, if the big servers are all putting everything on one key, then you can batch more. But yes,
I understand economies of scale and all that kind of stuff. Yes, of course. But I mean, and Eric was asking the contrast with, the DC solution, and the DC solution has the property of also making it better for the small guys, which is an advantage, I think.
I'm not sure I quite follow that.
Right, so we've cut the line, guys, because we have 2 minutes to do this, and I've heard a lot of support for this. So,
Kazuhoku, firstly, I just wanted to point out that this is a good idea because it essentially changes the cost of handshake from ON, where N is the connections, to O1, and I really like it from a DOS attack prevention perspective.
So at the last hour here, we think we're going to indulge. Hopefully you'll indulge me and stick around for the last 2 minutes so we can do these requests. There are a number of requests, or a number of people stated that they were in support of this draft. So I would also like to do working group adoption hums for this draft. So 2 questions, yes or no, basically. Well, let's start off with, are there people interested in working in this draft? If you are interested in working in this draft, please hum now. Can I have a show of hands of people that would be willing to contribute? All right, 5, 6, 7 hands. So let's do the formal hum. If you would like to adopt this as a working group item, please hum now. If you would not like to adopt this as a working group item, please hum now. Great, thanks. We'll take it to the list. Oh, it's yes for the minute taker. It was yes. Yeah, take a list of Center. Do you want to do me a favor? I made some tweaks to the CTLS message. Could you just read that real quick and I can send it like now? You want to hang out for 2 seconds? We can do an option. Do another option.